Understanding gas metal arc welding MIG pre-weld preparations. Gary Pace, PE welding engineer. Why in the heck does weld joint preparation matter so much for gas metal arc welding? Well, if we get the proper joint preparation going on, we're going to get the right amount of weld penetration, weld quality. We want to have weld quality across the board. Weld defects, we certainly don't want those, because if we're going to get a bunch of those, we're going to end up having to cut them out later on, and that costs money. Why do something 3 times when you can do it the first time right? And also it helps us with our welding codes and specifications. Gets us aligned with what the intent of the code is. You know, having a clean weld. So poor joint preparation is going to cause things like lack of fusion, incomplete penetration. We can have a bunch of weld repairs, which we don't want to do. Have a bunch of rework because we didn't do it right the first time, which is going to kill our welding cost. And inspection failures. This is all tied into one big adventure, and it's going to be painful if we have to do it this way. So clean it up first, weld it, and do it one time. So for pre-weld preparations, a lot of times we're going to have to take some steps before we weld with the gas metal arc welding process, or any process for that matter. This is going to include preparing the weld joint, fixturing the weldment if we need to, setting up the variables, and in some cases we might need to preheat the weld metal or the base metal before we weld it. So the amount of preparation that is going to be required before we weld is going to depend on, the size of the weld, what are we welding, what type of base metal, what's the fit up look like, how easy is this thing going to fit up, are we going to have to beat this thing into shape, or is it something that's just going to slide together? The quality requirements of the code or the customer, that's going to be a big one we're going to have to deal with. The governing code of specification. Also, the welder. Who have we got welding this thing? How much help are they going to need? Are they going to need this thing to be perfect, or what do we need? So when we're preparing weld joints, this is going to be, or we use, fillet weld, a square groove weld. So sometimes we can just square the edges of the members in the as received condition, or maybe we're going to have to cut them. Maybe we're going to have to cut, grind, use a plasma arc, shear to get the weld prep, the weld joint preparation that we're looking for. So when it's available, with the exception of shearing, thermal cutting methods, like oxy-fuel cutting or plasma or air carbon arc cutting, they're going to be faster than mechanical cutting methods. But we're also going to have to generally probably clean these joints up, especially if we use oxy-fuel cutting. Why does cleaning matter before welding with gas metal arc welding? Why can't we just burn it out? Well, this process isn't a burn it out type of process, because we're just using a shielding gas to cover our material that's being welded. So oil and grease, paint, coatings, rust, any of this stuff, dirt, moisture, these are going to cause problems with gas metal arc welding. We're going to get all kinds of issues. Porosity, the arc is going to be terrible. We're not going to get the proper amount of fusion in there. We can get spatter, and our weld quality is just going to be less than standard. So I can't emphasize enough why weld cleaning really matters before using the gas metal arc welding process. So with weld joint cleaning and grinding, welds made with gas metal arc welding are really susceptible to contamination during the welding process. So, if we got any grease, oil, paint, dirt, rust, or any other deleterious materials or foreign materials on that weld metal, we want to have it removed. A guy I used to work with, he told me that if, welding some metals, if it's not clean enough to eat off it, it's probably not clean enough to weld. So that goes for aluminum and materials like that. Irons and steel, probably not so much. But gas metal arc welding, I would say if it's not clean enough to eat off of, it's probably not clean enough to weld, because you're going to get some kind of contamination and it's going to cause weld defects. Um, this is really critical when you're welding aluminum and non-ferrous materials. Aluminum and titanium and these materials are really susceptible to, any kind of contaminants on the uh, base metal when we're welding. So, a lot of times, depending on what you're welding, maybe if it's aluminum, it might be cleaned with a solvent and some kind of vapor degreasing or something. These are options. You're probably not going to see that for your garden variety carbon steels, but it's possible. So when we're cleaning for MIG welding, gas metal arc welding, any kind of oil, grease, shop paint, any of that, it's got to be removed and from the metal surfaces, and it's got to be removed at probably 2-3 inches back, far enough out so that it isn't in the heat affected zone. Any kind of presence of this stuff, we can get arc instability and contaminated welds. So you got to have it clean before you weld with the GMAW or the MIG welding process. So why do we use fixtures and preheat? Well, alignment. If you just slap this stuff down on a floor and table and we don't have any kind of consistency, our alignment's going to be out of control. Distortion, fit up. Productivity is a big one why we use fixtures, because if you pre-cut the parts and just drop them in there, you're not fitting it up every time. So this can really save you, on your production time. Everything's cut, you just put it together like a Lego set and you weld it together. And it also helps with our weld consistency. If you're putting the same weld in the same place every time, we're going to have, a lot more consistency. As far as preheat, it depends on what materials we're using, but we're trying to reduce the risk of different types of cracking. We're going to try and slow the cooling rates. And when we're slowing the cooling rates, it'll allow some of our stresses to be relieved in our materials, and then weld quality, code requirements, and our mechanical properties. Maybe we can get a lower hardness if we use the preheat that we're required to use. Fixturing and positioning and weld backing is something that a lot of times needs to be addressed, depending on what you're making and how many of them you're making. Fixturing. I worked for a company, we made a lot of the same things, so we had fixturing. So, and this, would affect the shape, size, uniformity of the weld bead and the components. So, fixtures, these are devices that are used to hold the parts in a proper configuration or in relation to each other when they're welded. So, if we're not using fixturing, it usually means that we're not making a whole bunch of something, or that we can deal with the distortion, and that the distortion can be tolerated, or maybe we can correct it later on. The following is some of the functions of fixturing. Locate parts precisely within the assembly. So, if you're making a bunch of something over and over and over, and there has to be, there's a pretty tight dimensional tolerance on where the pieces need to be, we use fixturing. If there's alignment that needs to be maintained, we use fixturing. If we don't want a lot of distortion, we use fixturing. Maybe we use fixturing to control the heat buildup. Maybe that fixturing is going to, soak up some of the heat while we're welding. And it also helps with efficiency if you just plug and play and drop the parts into the slots where they need to go, and then you can just weld them up, as opposed to having somebody fit them up and figure out where they go and do it every time and tack it up. Sometimes just dropping them into a slot is a great way to really increase your weld efficiency. So with preheating, Preheating sometimes is required. It depends on what metal we're working with, what kind of base material, and the metal thickness. And also joint restraint, welding code. Um, you know, welding metallurgy is going to play a huge part into whether we need to preheat the base material before we're welding or not. And this will be given in our welding procedure, depending on which code we're working to. Um, the preheat temperature is going to be figured out by the welding engineer or a metallurgist or whoever wrote the welding procedure. And there's a lot of different ways we can preheat. There's furnace heating, electric induction coils, electric resistance, or sometimes we just use a big torch. There's a lot of different ways we can get the metal warm enough to hit the required preheat temperature for that specific metallurgical formula for that metal. Another one we look at is interpass temperature. A lot of materials that we weld, this kind of ties into preheat temperature, where we don't weld on a material unless it's a certain temperature. Well, interpass temperatures are important for different materials. So things like duplex stainless steels, we need to make sure that that material doesn't get too warm when we weld it. We put in a weld pass, and before we put in another weld pass, we make sure it's cooled down below a certain temperature. Or some materials, we don't weld on them unless they're above a certain temperature. So a lot of this is done to control the weld metal microstructure, and it also is going to ensure that the weld is similar to the welds that were made in weld qualification when we wrote our weld procedure. So sometimes we have a maximum interpass temperature and a minimum interpass temperature. We don't want to put we don't want to put too much heat into a material and ruin its mechanical properties, or we don't want to put too little heat into it and ruin its mechanical or chemical properties. These are some of the tools that we use for temperature measurement. A lot of times we've got like a thermometer, like they measure your temperature with when you're going into the doctor's office. They'll point that at your forehead and give you a temperature. Or we use these heat crayons. Heat crayons, each crayon has a different temperature, and it'll melt at a certain temperature. So you rub it on there. If it melts, it's at least that temperature. So we usually use heat crayons or these infrared thermometers. We can also really need to focus on, the base metal really needs to be sufficiently clean to meet the quality requirements of whatever code we're working to. Mill-induced surface defects, fins, tears, cracks, slag, or other base metal defects, depending on what code we're working for, we might have to remove those or clean those up. Scale and rust. These things need to be removed from what we're welding, and you need to bring it back adjacent to the weld. So you probably want to bring it back an inch, which would be 25 millimeters to probably 75 millimeters. You want to have a good clean area around whatever you're welding. Remove that mill scale and rust. A lot of times a hand brush isn't going to be able to remove it, so you might have to hit it with a grinder. Depending on which welding code you're working to, there might be other specifics that you need to adhere to, other rules you need to follow. So there's a thing called in-process cleaning. So this means that before we weld over a weld deposit, the previous weld deposit, we've got to remove all the slag, if there is slag, and adjacent base metal needs to be cleaned and brushed by some suitable means before we put in that next weld pass. This is just, it depends on which welding process we're using, but it's generally a good idea to run a wire brush over any weld you've made before you put the next weld bead on top of that. And a lot of times, wherever you cratered out with your weld, you might want to hit it with a grinder and clean up any cracks or any kind of um, instances of base metal discontinuities that might exist there. So just something to think about. Weld cleaning, interpass cleaning. When we put in a weld pass, we clean it. We put in another one, we clean it. So when we're done with the weld, we probably want to hit it with a wire brush and also hit the adjacent base metal and clean that up with a brush or a grinder. And this will take off any spatter that's remaining on the material so that we can, as we send it on to whatever's next in the manufacturing process, maybe paint, there's no little BBs or any, you know, crud left on the weld or the adjacent base metal. And it also might need to be cleaned prior to doing non-destructive testing. And, we don't generally weld these joints until after the welding has been completed and the weld has been accepted. Questions, comments, thoughts, concerns? Gary Pace, PE Welding Engineer, Katy, Texas.